All right, so we're going to talk about solving systems of equations. So what's happening here is we've got two equations with two variables, and we need to solve for each variable. Okay, there are a few methods to do this. This method that we're going to talk about here is called substitution. You'll see why it's called substitution in a minute. Okay, so here's the process. So the first step here says that you solve one of the equations for one of the variables. Okay. This step can be easy or it can be difficult. Sometimes you can make your life a bit easier if you make the right choice. We'll get into more on that in a minute. The second step is to substitute your result from step 1 into the other equation. It's important that you substitute into the other equation, because if you substitute into the same equation, you're just going to end up going into an endless loop that you can't get out of. Step 3, then at this point what you're going to have is one equation with only one variable in it, so you'll be able to solve that equation for that variable that's left over. And then step 4 is to substitute your answer that you got into any of the previously mentioned equations to find out what the other variable is. Okay, so let's get into an example here. So the first example here, as you can see, so 2x minus 4y equals 7, and 4x plus y equals 5. So as you can see, you've got two variables, the x and the y. We're going to find out what x value and what y value make these two equations true at the same time. Okay, so the first step, as we mentioned, is to solve one of the equations for one of the variables. All right, so the choice that we make in this step can make our life a bit easier depending on what we do. So I could solve either of these equations for any variable. So how about if I, for example, choose to solve the first equation, so this one right here, 2x minus 4y equals 7 for x. Well, just watch what happens for a second. Well, if I'm solving for x, then I need to get rid of this y term. So since this is a minus 4y, I would have to get rid of it by adding 4y to both sides of the equal sign. So I add 4y here. Of course, negative 4y plus 4y gives me 0, so this cancels off. If I add it on this side, then I need to add it on that side as well. That, of course, gives me 2x equals 7 plus 4y. Now, to solve for x, I need to get rid of the 2. Okay, so what I would have to do is divide both sides of the equation by 2. This, of course, is going to get rid of the 2 that's up there. So now I need to divide 7 by 2 and then 4y by 2. So, of course, 2x divided by 2 just gives me x. 7 divided by 2 isn't a nice number, so I have to leave it as is. 4y over 2 is really just 2y. So here I find that x is equal to 7 over 2 plus 2y. Typically, we don't like to deal with fractions if we don't have to. Sometimes you can't avoid it. So in this case, this isn't ideal. However, if we go back to the beginning and look at the equations we have, we might notice that this term here, it doesn't have a coefficient written. So since it doesn't have a coefficient written, of course, it's assumed to be a 1. So I can see, then if I try to solve this second equation for y, all I would really have to do is to get rid of this 4x term, and then I would have it solved for y. I wouldn't need to divide by anything, because this is already just 1y. As such, I'm going to have an expression that's a bit easier to work with. So let's just confirm that for a second now. So if I solve equation 2 for y, then I write my equation down. Okay. To solve for y, I'd need to get rid of this 4x term. This is a positive 4x. So to get rid of positive 4x, I would have to subtract 4x from both sides of the equation. Subtract 4x there. 4x minus 4x gives me 0. This cancels off, leaving me with just y here. And then, of course, I've got 5 minus 4x. So not only is this step easier and quicker to get the answer to, I also know that have a simple expression here to work with for the next step. So you pick your choice. Which would you rather work with, this expression or this one? I know which one I'd prefer to work with if given the choice. So when you're doing this first step, what I typically do is look for a coefficient of 1 on one of these variables, and that's what I solve for, so I don't have to do division. Or if none of these are 1s, I try to pick which variable I solve for so that everything comes out to be as nice of a number as possible. So now, since we've just found that y is equal to 5 minus 4x, I'm going to go to step 2. Remember, step 2 is to substitute that result into the other equation. So I took equation 2, got this, so that means I'm going to take this and substitute it into equation 1, so into this one up here. Okay, so moving on to that next step, I'm going to take this and substitute it into the first equation. So that's my first equation. All I'm going to do is take this and put it in place of my y right there. Okay, so I'm going to be left with 2x minus 4. So there's the 2x minus 4. Now y goes right here underneath my finger, and y is 5 minus 4x, so there's my y term. Okay, and then of course I have equal 7 right here. Now what you notice is I've got one equation with just a single variable in it, so I can quite simply go ahead and solve this for x, which is of course the third step, which is to solve for the remaining variable. Okay, so now I can see here that I have a distributive property here, so this is going to be negative 4 times 5 and negative 4 times negative 4x. Which of course is going to give me 2x minus 20 plus 16x equals 7. Okay, so 2x plus 16x of course gives me 18x. So then I've got 18x minus 20 equals 7. To solve for x here, I'm going to need to get rid of this minus 20. So to get rid of subtract 20, I would add 20 to both sides, add it to this side, add it to that side. Of course, negative 20 plus 20 gives me 0, so that cancels off. 7 plus 20 gives me 27. So I've got 18x equals 27. Now to solve for x here, I need to get rid of the 18, so I'm going to divide by both sides by 18. Dividing by 18, dividing by 18, okay? And then I can just reduce this fraction down. These are both divisible by 9, so I divide them both by 9 to get 3 over 2. Now, I have my x value. What I need to do now is try to find out what my y value is going to be, okay? So I'm going to take this x value, which is 3 over 2, and substitute it into any previous equation that we've come up with, really. What I like to do is to go back to my result of step 1 right here, because you notice if I know that x is 3 over 2, then all I really need to do is put 3 over 2 in right here for x, and then I have y from there. So from here, I would just take this little equation that I came up with. I would take x as 3 over 2 and plug it in. So I would have 5 minus 4 times 3 over 2. Okay. So now I can write this 4 as a 4 over 1 times 3 over 2. Now to multiply fractions, I multiply my numerator by my numerator, my denominator by my denominator. So that gives me 4 times 3, which is 12, over 1 times 2, which is 6. So 12 over 2 reduces down to 6. So I know that this stuff right here essentially just comes out to be 6. So that's 5 minus 6, which is of course negative 1. So now my answer would be that x is 3 over 2 and y is negative 1.